Welcome to Ken Matrix Online Academy. In this tutorial, we are going to learn about three-dimensional geometry. For XE and IGS exam help preparation and online coaching, contact WhatsApp 079 051 0099 or email mwemican3@gmail.com. Stick with us up to the end. Let me take this humble pleasure to invite our tutor engineer Ken Mwima to lead us in the tutorial. Welcome, sir.
Thank you very much. Thank you. So, the topic of this particular tutorial is three-dimensional geometry, like it has been introduced. The outline of this particular video tutorial is as follows. We are going to look at introduction, where we are going to see what three-dimensional geometry entails. And then we are going to look at the history of three-dimensional geometry. We are also going to introduce ourselves, or rather revisit some few concepts on trigonometry and Pythagoras theorem, which will be of significance to these particular computations involving 3D space. The next thing that we're going to look at is examples involving the cuboid, another example involving rectangular-based pyramid. The last example will be a triangular-shaped cross-sectional prism. In those particular shapes that we have mentioned, we will be looking at the lengths and the angles. On to the introduction. What is the 3DG? 3DG means three-dimensional geometry. It is the mathematics of shapes in a three-dimensional space, or we can call it in three Euclidean space. The shapes that we are talking about are pyramids, prisms, talk of cuboid, talk of cones, and etc. Now, let us not confuse ourselves with the Euclidean, because Euclidean vector spaces is vector spaces that defines the dimensions, but here we're talking about three-dimensional vector spaces. Now, let us now come to see what are the developments of this particular concept. Fermat and Dectis, these are the pioneers, said to be the pioneers of three-dimensional geometry. Their work focused on curves and surfaces in a three-coordinate system. But their work was developed by Swiss mathematicians Leonhard Euler and Jacob Hamann around 1730, where these guys were doing what is known as analytical geometry, and they developed concepts that are very significant, very important in a three-dimensional geometry. On to the trigonometry and Pythagoras theorem. I know most of us are familiar with this, because you have to. As far as three-dimensional geometry is concerned, this has to be taken care of. So, a quick review of trigonometry and Pythagoras theorem is as follows. Let's say that we have a triangle and it has the following sides. Let's call that side A, and let's call this side C, and let's call this side B. And I say that, assuming that this is a right angle triangle. So, a quick review on trigonometry, and let's say that is the angle theta, is the angle theta. So the cosine cos theta is equal to, in our case, in our triangle there, is equal to B over C. Sin theta is equal to A over C. And tan theta is equal to A over B, opposite over the adjacent. So that is basic trigonometry. Let us look at Pythagoras theorem. Let us redraw the triangle once again and have a look at the Pythagoras theorem. They say that we don't need theta. They say that is C, that is P, and that is A. So C squared is equal to B squared plus plus A squared, or rather we can say B squared is equal to C squared minus A squared. We can also express A squared. We can express A squared as follows. A squared is equal to C squared minus B squared. So now let us, now that we have introduced ourselves to trigonometry and Pythagoras theorem, let us now go straight to the examples. We are going to do our first example. Now, I didn't give the shapes of this particular three-dimensional figures, but I'm going to mention what they are in the examples. Now, this is called a cuboid. It is a spatial prism with a uniform rectangular cross-sectional area. So we have our rectangle as shown. Let us read the question. The diagram below represents a cuboid of A, B, C, D, E, F, G, H, in which FG is equal to 4.5 centimeters, GH is equal to 8 centimeters, and H is equal to 6 centimeters. So let us go to the question and see the requirements. Calculate the length of FC. Calculate the length of FC. Now, here we have our triangle, and we want to calculate the length FC. The length FC, this length here that has been highlighted in red, the length FC. We want to calculate that length FC. Now, and then we also have something like a shadow. We can call it a shadow, when as the sun, or rather the light, has been cast just above the line FC, and maybe the shadow of that line is line FH. So looking at that formation, we can extract a triangle from there. So let us extract a triangle. Let us extract a triangle. So the triangle will be that. Let's say that let's say that is the triangle, and then we have theta, and then we have 6 centimeters, and then we have 8, but we don't know if let me use a different color. We don't have FC. So how do we get to find let me correct here. Let me make this correction. So, but now you realize that this is a H, this is a H, this is a H, but you realize that we don't have the distance, FH. We only have GH. We don't have the distance FH. So how are we going to get the distance FH? Another triangle formation is already there that can be used to get FH, which is triangle FGH, this triangle below. So maybe we can extract another triangle. Another triangle of that form, so that this is the FH. This is the FH, and this is 8, while this is 4.5. So as we can see, we have to get FH. How do you get FH? You can see there is a triangle formation. So assuming this is the triangle, this is our hypotenuse FH, this is our A's and B. So how do we get FH? So FH squared from the Pythagoras theorem is equal to 4.5 squared plus 8 squared, then get the square root of the whole summation, and then the answer will be 9.2. Why are we saying 4.5 squared plus 8 squared? We are saying that because these are the shorter sides and we want the longer side, this longer side here, FH of this triangle from below. Now that FH has already been determined as 9.2, so the next thing is to get FC. So how they should be FC this should be FC. and then this should be FH, FC, FH. So FC is equal to 9.2 squared. So what is 9.2 squared? 9.2 squared is this length here. 9.2 squared plus 6 squared, which is HC. HC 6 squared. HC, that length there, which is 6. So it is 9.2 squared plus 6 squared. Just to note one thing is that we are applying Pythagoras theorem, and we have to identify which is the longest side and what are the shorter sides. These are the shorter sides, this triangle. So the Pythagoras theorem will give us as follows: FC is equal to the square root of 9.2 squared plus 6 squared, and the answer is 10.97. So 10.97 is the length FC, Okay, let us go to the next part of this problem. Find the size of the angle between lines FC and FH. This is line FC, the lines whose length has already been determined, and line FH. So we ought to find this particular angle. Let me highlight the angle in the diagram. It is this angle we are interested in. This particular angle that is right between the line FC and the line FH. But you can look at the relationship. This FC is the longest side and FH is the shorter side that is just adjacent to this angle. We have an option of using cosine theta, or we have another option. We already have this side which is opposite, and then we have this side which is adjacent. We also have the hypotenuse. So in this example, we have decided to use the relationship between this CH and this 9.2 FH, 9.2, so that opposite over the adjacent FH is equal to tan theta, and theta, so opposite tan theta is equal to 6 divided by 9.2, which is 0.6522, and theta is equal to tan inverse. So when you want to get theta from the calculator, make sure first of all it is set in degrees, not in radians, and then you press shift, press tan, then you press these digits 0.6552, then press equal key. Next question, find the size of angle between lines AB and FH. So where is line AB? This is line AB. Now we need to know that line AB is parallel to line FG. Line AB does not lie in the same horizontal plane as line FH. So it will require us to open our eyes wide and look at the relationship between AB and FG. What is the relationship? The relationship is that the two particular lines are parallel. And if we can be able to understand it that way, we can consider the relationship between FG and FH, so that we treat AB as if we treat AB as if we are treating FG. And now how do we do it? we can see we have a triangle formation there, F, G, H. That's the triangle formation, and we want to get that particular angle that is 90 degrees, and we want to get this particular angle, this angle there, that is, let me mark once again, that is marked in yellow. This is the angle we want to find, the angle between the lines AB and FH. So, like we have said, a line AB is parallel to line FG. So we are going to treat AB as if we are treating FG. So this is what we're going to use FG, because AB does not lie in the same horizontal plane as FH. So considering FG as the angle in considering angle HFG as angle of consideration, this angle there, this is 90 degrees, so this is a right angle triangle. So you can use trigonometric tan relationship, whereby maybe if I can draw this triangle there, I can try to see whether I can draw it. That is the, wow, what's happening? That's the triangle. This is 8, and this is 4 points. Let me avoid that. This is the triangle we are talking about. So if this is the angle in consideration, if that is the angle in consideration, then we are going to treat this GF, okay, AB, rather GF as the opposite, and FG as the adjacent, and the opposite over the adjacent is equal to tan theta. So that will be 8 over 4.5. Tan theta is equal to 1.7750, and tan inverse of theta is 60.60 degrees. On to the next example. Find the size of the angle between the planes ABHE and plane FGHE. Plane FG, plane FGHE, and plane ABHE. So this is the angle in consideration. That is the angle in consideration. And remember, note that this is 90 degrees. Now that according to the solution that has been provided here, it's using a cosine rule relationship, but I'll show you shortly an alternative method and you'll arrive at the same solution. So considering this as this is 6 already, we want the angle C, maybe that is angle C, this is A, and then this is B. How do we get B? Or how did B get how do we get B? B is just 6 square root of, it's just the square root of 6 squared plus 8 squared, and then you get 10. And in the solution here, we have used the cosine rule relationship. And 6 squared, treat this 6 as our c. This is 10, b is 10, and a is 8. And this is the cosine rule, but there's a shorter method to this. There's a shorter method, and this is the method that I urge us to use. We can use tan relationship now that we have now that we already have 6 as the opposite and 8 as the adjacent, so we can use tan theta is equal to 6 over 8. Six over 8. So get the tan inverse of 6 over 8, see whether you're going to get this answer. And that is a shorter method. We're just trying to help you try to recall the cosine rule, and so that you can be able to relate. So that is it in that particular area. Let us go to the next question. So this is question number 2, or rather example number 2. And what do we have at hand? We have a rectangular based pyramid, and that is on top of a cuboid. So this is a rectangular based pyramid. You can have a square based pyramid. This is a square, but also a square is a spatial rectangle. So it is true to say that it's a rectangle. So this, maybe to be specific, we can say it is a square based pyramid. A square based pyramid. The lengths are already shown. VC, the slant height, 17√2 meters. The height, 8 meters, the height of the cuboid. And the length, 15√2, the length of the base, the cuboid. So let us go to the question. But before we go to the question, let me read the question. The figure below shows a right pyramid mounted on to a cuboid. AB is equal to BC is equal to 15√2 centimeters. CG is 8 centimeters, and VG is 17√2 centimeters. Now let us go to the solution. Calculate length AC. Calculate length AC. This is the length we are talking about, the ones that have been marked in green. Length AC. Now once again, there is a triangle formation, triangle A, C, B. That triangular formation there will help us to get length AC. Since AC is the longest side, and when we have other shorter side, we're just going to say AC is equal to square root of 15√2 squared plus 15√2 squared. This 15√2 squared plus 15√2 squared, the square root of all of that, you get 30 centimeters. This is 30 centimeters. So that is how you get AC. Let us go to the next. Find the angle between line AG and plane ABCD. Plane ABCD. Now let me try to use my pen to show the plane. This is the plane here we are talking about. We want the angle between the line AG, and the line AG is this, the one that has already been marked, and then we want to see the plane. So that is what we're going to do. We want to get that length. We are going to use the length, the hypotenuse. We want that angle, that is the one that we need. Do we have AG? Let us check whether it is there. We only have AC. So we have AC. Now, this is AC. We are going to use AC, the one that we found previously. 30 centimeters is the one that we're going to use it here. And we were supposed to find the angle between AG and AC. Now, once again, this is at another triangle formation, AGC. AGC. Now, we have AC already as 30, and we also have GC. So it is very easy to get the angle. GC is 8 centimeters and AC is 30 centimeters, the one that we've just found. And now we want to get this angle. Now that we have an adjacent and the hypotenuse, we can use tan theta relationship. So tan theta is equal to 8 over 30. And tan theta is equal to tan inverse of 8 over 30, which is 14.93 degrees. On to part C of this particular problem. The vertical height of point V from the plane ABCD. Now let us look at the vertical height. The vertical height of this cuboid. The vertical height of the cuboid itself. And also the vertical height. So here there are two heights. There is that of the cuboid and that of the pyramid. Now so this is the height. So we want to get this height and this height, then you total them together. Now let us start with the first height, the height of the pyramid. Look at this point. I'm going to say let this point be O. Let that point be O. So looking at this point, it forms this triangular relationship. Call it VOG. VOG. Now, because EG is parallel to AC, the one that we have just determined as 30, so automatically EG becomes equal to 30 centimeters. And since this is assumed as the center, though we are not having a true view, always three-dimensional figures are not in three views. So, they're not in a clear view. So we're going to assume this as the center. So the distance from O up to this is 15 centimeters. This distance from OG, call it OG, that is 15 centimeters. So how do we get the height of the pyramid? The height of the pyramid is OV, is 17 root 2 squared minus 15 squared. Remember, in this triangular formation, this is the longest side and this is the height. This is the other shorter side. We want to get the height, so we are going to take 17 root 2 squared minus 15 root squared minus 15 squared. Get the square root of that. How are we going to 15? Once again, from here to here is 30, so 15 is a half of from here to here. I mean the distance from the center to G, so that is 15 centimeters. And the height of the pyramid is 18.79. Now, what is the height of this particular cuboid? Is 8 centimeters. So the total height is going to be 8 plus 18.79, which is 26.79 centimeters. The next is to get the angle between planes AEFV and ABCD. So we are going to say let tan alpha be equal to 18.79 over 7.5 root 2. But let us see how this is coming up. We have seen the height. The height has already been determined. This height here, which is 18.79 centimeters, and it is the same height we are going to use, the distance from there up to there. The distance from here up to here is the same as the distance from this point up to this point and here, 15 centimeters, 15 root 2. So what is the distance from this point to the center? Is 15 root 2 divided by 2, which is 7.5 root 2, this one here. So in other words, this is the triangle formation and this is the angle in question, and the distance from here up to here is 7.5 root 2, and the vertical height is 18.79. So tan alpha, assuming this angle to be alpha, tan alpha is 18.79 over 7.5 root 2, and alpha is 60.55 degrees or 60.56. Let us go to the last question, and this question focuses on this particular solid, which is called a triangular cross-sectional prism. Now, let me read the question. The figure ABCDEF below represents a roof of a house. AB is equal to DC, which is equal to 12 meters. BC is equal to AD, which is equal to 6 meters. ASE is equal to BF is equal to CF is equal to D is equal to 5 meters, and EF is equal to 8 meters. So you already have the diagram. Let us go straight to the requirements of this problem. Calculate correct two decimal places the perpendicular distance of EF from plane ABCD. This is the plane talking about, plane A, B, C, D. So we want to get the vertical height, this height, that is marked in brown. That particular height is the height that we are supposed to find. Okay. Now, we need to know what is provided and what is not provided. What is this length here? This particular length that I have highlighted in dotted pink. Is it dotted pink or purple? Dotted purple. It is the same length, the slant height, different slant height. So we have to get a slant height first. It is very easy to get this base, the line marked in green. It's very easy because we're going to say 6 over 2 divided by 6 divided by 2, which is 3. So this length is 3. We need this in order to get the vertical. How are we going to get this length, which is the same as this length? So let me just talk about it briefly on how to go about it. We we can see that since this is a triangle, we have this side. Now the distance from here up to here is 12 centimeters. So 12 minus 8 is 4 centimeters. So from here to here is 2, and then this is 5. So 5 squared minus 2 squared, the square root of all that, you get 3. So that length there is 3. This length is 3 centimeters. The length is 3 centimeters. You're going to see that in the solution, so you don't need to worry. We're going to see that. So now if that is 3, the length 5 squared, so let us go to the solution. Is it 5 squared is 25. 25 minus 9 is 16. Sorry, this is supposed to be 4. This is supposed to be 4, not 3. Supposed to be 4. So let us go to the solution and see. So like I have said, we have to be to get that slant height, the distance EF from plane ABCD, because the distance EF from plane ABCD, so that distance, so that is the slant height 4 centimeters. So after getting the slant height, how will it be helpful for us? We have that as 4, and we already have this base as being equal to this base being equal to 3 because of 6 divided by 2. So let us go to the solution. What's the distance EF from the plane ABCD? So that will be 4 squared minus 2 squared. So the distance will be 4 squared minus 2 squared. So what is 4 squared? 4 squared is 16. 2 squared is so let us look at that and look at that once again. So this distance here is 2. The distance is 2 because this is 2. So the distance of EF from plane ABCD is the square root of 4 squared minus 2 squared. Once again, this 4 is the longer side and this 2 is the shorter side. We want another shorter side. So how do we achieve that? And that is how we get 4 squared minus 2 squared is root 12, which is 3.46 meters. Let us go to the next question. Calculate the angle between planes ADE and ABCD. Planes ADE, planes ADE and planes ABCD. So we are going to take the center lengths, the one marked in green and the one marked in yellow. But point to note is that this angle here I've marked, highlighting, is 90 degrees. and we want to get this angle here. So we are going to use this height, the height that we already found as 12, root 12 or 3.46, and after getting that, we are also going to use this particular length there, the ones that is marked in green, or rather we can also use this length here below. Let us go to the solution. Angle between planes ADE and ABCD. So this is just simply tan inverse of root 12 over 2. So root 12 is the height to that distance there, the distance from here to here 2. That is the distance we're talking about, 2 centimeters. And mind you, you need to know that so that is 2 centimeters. So tan inverse gets 60 degrees. Let us go to the next question. Next question. Find the line AE and plane ABCD. The line AE and the plane ABCD. So we have this line AE, this line E, the vertical height. The vertical height is still root 12, which is the same as 3.46. Then we have this distance AE. Now that we already have this height and we have AE as 5, it will be very easy to get that angle. Why are we using this line to represent the plane? Because it is the center line connecting AE, the center line connecting AE, the center line of the plane, the whole plane, the bottom, the rectangular bottom. So go to the solution. Is sine inverse of root 12 over 5. Why is saying sine? Because it is relating this opposite and this hypotenuse AE. So sine inverse of root 12 over 5 is 43.9 degrees. On to the next question. The planes ABFE and planes DEFC correct to 1 decimal place. We want to get the angles between the plane ABF. Follow how I'm highlighting. A, B, F, E, and planes D, E, F, C. I've just drawn these lines to represent the plane. This line represents the lines that are drawn in the center part of these particular planes to represent the planes. So we need the whole of this angle, the whole of that angle. We know this side, that side. In the case we have forgotten, let me take you back a little bit. This is the side we are talking about. We already have it as 4 centimeters. This is 4 centimeters. We already have the height, so we can be able to get this angle here. So how do we get the angle? The angle is just tan inverse of 3 over root 12. Why are we saying 3 over root 12? Why are we saying tan inverse of 3 over 12? The distance from here to here is 3. The distance from this point to this point is 3. And because that distance is 3 centimeters, we are going to use root 12 related to 3. So we say root 12, which is the opposite, divided by the adjacent. And the tan inverse of this is is closely maybe equal to 40, maybe point 45, rather 40.5, 40 point something, and then you multiply by 2, you get 81.2, 81.8 degrees. Why are we multiplying by 2? Remember, just note this, note that we want to get the whole of this angle. We want to get the whole of that angle, but we can get that angle. So we are multiplying by 2 because we want to get the whole of this. Since this angle, since that angle is similar to this, is equal to that, we just simply multiply by 2 and get the angles between the two planes. Thank you, and that is the end of our presentation. Let us meet in this next video tutorial.